got nebulizer gas on it.
Yep.
And ordinarily, your nebulizer gas plugged into there. There's a label on there as well.
Yep.
So if this was a regular ESI source, that line would be plugged into where that orange plug is now.
Yep.
But we need a bit more pressure than we can achieve from that line there. So we are plugged into here directly.
Yep.
And this is a valve. So to turn the valve on, you lift that up so it's flush with the top. And you can actually, if you put your ear there, you can hear. You won't hear from that speaker probably, but do you want to?
Yeah.
You can hear it, can you?
Yeah.
So when you turn off and on, yeah. Okay. So now you've got nebulizer gas, and you can see peaks here already before we've done anything else. So that's a good indication that things are working. Always recommend click this button here, smooth data. So you can see the peaks look a bit ropey now. If you click smooth data, they look nice and Gaussian. So the good news is you've got capillary action at the moment, taking these tune mix through the red peak into the source. Because remember, there's a venturi effect in that source, and so it's physically sucking the tune mix through anyway. So there's no need to turn this on. So ordinarily, if this was a regular source, you'd have to turn this on to pressurize the vial with the tune mix in. But because we've got such a high venturi effect on this, we don't even have to do that.
So that's only on the OPSI, not on the regular
Exactly,
ESI.
yes.
And on the APCI probe, you'd also have to pressurize.
You'd have
as
to
well.
pressurize it,
Yeah, if that was attached. Yeah.
So you've got the peaks.
Yep.
So to calibrate, go to tune and then calibrate. And this takes a little while. And don't be concerned that sometimes the peaks disappear. It's just moving to a different part of the window to look at the noise in the window.
How often do you recommend calibrating it? Would you say, is it sort of every few weeks or
I'd do it once a month.
once a month? Yeah.
In fact, this calibration that was on, actually not here, but on that mass spec, it was almost perfect. And I don't know when you last calibrated it, but it was almost perfect. So it's quite stable. Yeah, now you have to hum, so it's no dead air. Right, so you see once that's gone away, it's filled in this performance table here, and it's also filled in the calibration table. So the performance table is telling us that the measured mass, it better be the same as the reference mass, because we just calibrated it. So you would expect these numbers to be the same now.
Yeah.
Okay. The resolution, what we're trying to aim for, is between 0.5 and 0.7, and that's referring to the width of the peak. So you can see the isotopes, which is what you want, because that's going to help you identify, especially compounds such as chlorine, bromine, that have got very unique isotope patterns.
Yeah.
So you definitely want that sort of resolution. As resolution goes down, intensity goes up, and vice versa. So then it also completes this table here, and this you can see is just a mathematical graphing correction really. So it's just correcting for any slight differences in the physical characteristics of the mass spec, to go to make sure when it says it's 118.08 it is indeed 118.08.
Yeah.
So we've done the calibration, so now we have to save it, and that's going to be default positive. Okay, so that's all done. So now we need to do the negative, so we just flip this one here to negative iron, and right now it's loaded some not arbitrary values, but these are the sort of installed default values, so these aren't going to be any good. So we put this to ESI negative now. I'm just going to check this file, this is fine, yep. So in order to bring up the correct values, I'm going to open, say, default positive file. So these are the same values that I used in positive, but are just now they've been changed to negative values. And so now I've got my peaks, and I can do the calibration again. So now it's going to do the calibration in negative iron mode for the negative iron reference peaks.